All right, in day 2 of scientific notation, we are still talking about expressing very large or very small numbers using scientific notation. Thinking about how scientific notation actually helps us in both representing large and small numbers and ordering large and small numbers. So we'll get into ordering today. Quick announcement, on the 23rd, Thursday, we will have an MYP task formative. Today we'll do a quick solo check-in as a warm-up, card sorting activity where you're matching standard form to scientific notation and matching to like real-life objects, just to give us kind of an anchor to attach certain values to. And then a little bit more practice, especially with ordering scientific notation. So this should look familiar. It's more problems like what we were doing yesterday. So I want you to go ahead and pause the video and take a minute to work these out on your own. Please don't check in with your partner until we go over the answers. I just want to remind you, if at any point you are not understanding something on a particular slide, please use the Padlet link on our classroom to leave that feedback so we can address it at the beginning of the next class. All right, so in the first couple of examples, we are converting numbers that are already in standard form to scientific notation. And as a reminder from yesterday, when we're talking about scientific notation, we want to end up with a number that is greater than or equal to 1 but less than 10, and that's where I need to put my decimal point. This one, my decimal point needs to be after the 6. So this number, 6.0000, because that 2 is there, I need to include all of those zeros. That 2 is a significant digit. Now I need to think about, well, how many places did I need to move that decimal point in order to create that number of 6.00002? I needed to move it 2 places. Next example, I have this number 3 billion. And right now, again, the decimal point is at the end when we can't see it. And in order to write this correctly in scientific notation, I need for it to be right there because that is a number that is bigger than or equal to 1 but less than 10. And so these are all zeros. I absolutely do not need to include them. I don't need to write 3.000000000. That's not necessary. I can just write 3 times 10 to the, I had to move from here, 1, 2, 3, 4,
Miss
5, 6.
Webster. Miss
Sorry for the announcement in the middle of that. We were counting at 6, 7, 8, 9, 10 to the 9th power. Remember, it's a positive and not a negative here. If I said -9, I would be saying that I started out with a really small decimal, a number that was way less than 1. Sorry guys, I keep having to pause this for noises in my office with printing and people coming in. So I'm just going to keep trying to pick up where I left off. But these bottom examples are taking numbers from scientific notation and going to standard form. And so this 2 is telling us we're moving 2 places. And the positive 2 is telling us we're moving 2 places to the right. So 1, 2. And this number in standard form is 400. Oh my goodness. 422. This one is telling us we're moving 6 places to the right. So I'm going to move over 1. And then I've run out of numbers. So I need to add 5 zeros because I still need to move 5 places. All right. This next activity, I'm going to ask you to pause the video, but you should have gotten a set of cards that looks like this. They're all cut out though. So you have decimal notation on one and scientific notation on the bottom. And then on the second page, you have all of these pictures of real life examples. And your task with your partner is to match them up. So you are going to match each number in decimal or standard notation with its partner that's in scientific notation. 2 cards won't have a match. And you have some language frames here to help you frame your conversation that you're having with your partner. So I think blank and blank are a match because, and then your awesome reason why. Then you are going to, once you've made that match, I encourage you to do that first and get all those pieces out of the way. you want to match each real-world example with one of the matches that you made. And we're practicing making estimates for kind of giving us an idea of, sure, it's 4 times 10 to the 8th power meters, but really, what does that represent? So go ahead and pause the video so you are able to do that. So at this point, I'm going to ask you to just check in and see how you did with that activity. Again, if you have any questions, anything that doesn't make sense, go ahead and post that on the Padlet, and we'll talk about it first thing during the next class. So what we are going to work on next is starting to think about how different numbers in scientific notation compare to each other. If I am talking about positive or negative exponents in my scientific notation, the very first thing that I want to look at when I compare numbers is the power of 10. And so what I mean by that is I'm looking at this first example, and one is 10 to the 9th power and one is 10 to the 10th power. Now they're both written in scientific notation, and I look at the powers and I say, well, to the 10th power would be larger than 10 to the 9th power. If they're not both written in scientific notation, the first thing you would want to do is make it so that they are. And so I would want to rewrite this as I needed to move this one to 1.234 times 10 to the negative 2nd power, since I had to move that 2 places in order to make that number. And so these two are equal to each other. I want you to pause the video and try the remaining 4 on your own. And please do not continue to the rest of the explanations until you've tried that. Okay, so if you're continuing, that means you've tried the other 4. And again, if I go over these and something doesn't make sense, tell me that on the Padlet. 10 to the 0 power is 1. And 8 times 1 is 8, and so 8 is less than 80. Now, notice I did not change them both to scientific notation in this case, but I could have. I could have made this 8 times 10 to the 1st power. I just thought it was easier to simplify the one on the left to 8, but either one is okay. This one, I'll go ahead and write this as 9.7 times 10 to the 6th power, because I had to move that decimal point 6 places. And so I'm looking at 10 to the 5th power as compared to 10 to the 6th power. 10 to the 6th power is greater. Now, be careful here. So I have negative numbers. I have, which you can't see anymore because I covered that up. So I have negative numbers as my powers of 10. Remember how negative numbers work. The closer you are to 0, the bigger the number is. Negative 3 is closer to 0 if I'm thinking about a number line than negative 5, and so this quantity on the left would be larger. And then don't be thrown off here. One's positive, one's negative. That 7th power is way bigger than to the negative 8th power. And one quick note before we move on. If I had a situation where the powers of 10 for both numbers were the same, so let's say I just had something like 3.3 times 10 to the 4th power, and I was comparing that to 2.7 times 10 to the 4th power. So both of these involve 10 to the 4th power, and so I need a different strategy to solve this kind of a problem. So I want you thinking about, well, what do you think I should do before you listen to my explanation? So pause, think about it for a second. And again, if you're listening right now, it means you thought about it for a second. But the one that I should pick is the one where what we call the lead factor is larger. So we first want to look at the power of 10. But if that's the same, then we want to look at what we call our lead factor. So this 3.3, this 2.7. And whichever one is larger would be the larger value. And 3.3 is larger than 2.7. This next section you may work through with your partner, and we are first going to use scientific notation to represent each of those expressions, and then we are going to order them from least to greatest and describe how we did that. So take a few minutes, pause this video, and work this out with your partner before you go on. Okay, so if you're continuing to watch, that means you and your partner have worked out these problems and now you're ready for these solutions. So in this first problem, I need to make this. I'm going to stop going through solutions so slowly. I moved that decimal 11 times to get from where it was at the end of the number to between the 4 and the 6. In example B, I moved the decimal point 1, 2, 3, 4, 5, 6 times, negative 6th power. This is a weird one because I've got already a decimal and already a power of 10, but it's not scientific notation because that lead factor is not between 1 and less than 10. So I need to make this 9.274. And in order to do that, I moved my decimal point twice. Again, this looks half right because I already have a lead factor that's in that right range, but I need to rewrite that to be scientific notation as 10 to the 0 power. And just a side note, you would probably never do this because we usually use scientific notation for very large or very small numbers. However, for the practice of what the concept is and making sure you've got that down, this is good practice. So knowing again that 10 to the 0 power is 1. In this one, I need to move this 2 places to have 1.1. And this one was tricky too. Hold on 1 second. Sorry for another announcement. So now we have 1.1 times 10 to the, what do we do now? So we already had 10 to the negative 3rd power. And I just moved it 2 more. So negative 3 plus another negative 2 means that I'm at 10 to the negative 5th power. Now if I move that 5 places to the left, I wouldn't end up at this number that I started with, but I would end up in an equivalent form in standard form. And finally, this needs to be 7.26. It was 10 to the negative 1st power already, and I just moved it over another one. So this initial number in standard form would be 7.26 times 10 squared. And now we want to go ahead and order these from least to greatest. Go ahead and just slide this out of the way so I have more room to move these guys around. And now up here I'm going to say this is the least, these are the smallest values, and I'm just going to make a list that goes down to the greatest. Make sure you have tried this with your partner before you're just looking for my explanation. Now, we mentioned before that when we're ordering numbers, we don't even need to look at these lead factors until we've taken care of ordering the exponents, or the powers of 10. And if I'm looking at all of my powers of 10 and I want the smallest, I notice I have some negatives. And so for me, the least is going to be, well, whichever one is further or furthest from 0 in terms of negative numbers. So it looks like I have a negative 6 and a negative 5. And if I'm putting them in order, this 1 to the negative 6th power is going to be smaller than this number, which is to the negative 5th power. Now I notice that I have a to the 0 power, and all I'm left with are positive numbers. And so as I do this, I notice that I have a to the 2nd power, to the 2nd power, to the 11th power. That one's certainly going to be the largest number. Now remember what we said. If the exponents are the same, which they are, 2 and 2, then I need to look at those lead coefficients, the 7.26, the 9.274. Well, the 7.26 is smaller, which means that that entire number in scientific notation is smaller than the 9.274. And that is an overview of how we order numbers in scientific notation.